Hello everyone, welcome to the teaching video of Hisense VRF selection software. Firstly, launch the software. Software can be used in two cases. One is used for material statistics, price calculation, and report after the equipment selection has been done. Another case is a complete selection process. From project establishment, load calculation, equipment selection, to equipment layout, pipeline connection, system output calculation, and report. Now, I will demonstrate a complete selection process by using our Hisense VRF selection software. Before we start a new project, we should do the system setting. System setting. As we can see that the system setting mainly includes three aspects: project configuration, unit setting, and other settings. First of all, let's have a look at the project configuration. Current region. Select the project area scope. Mainly includes these areas. I select all regions for this demonstration. Current country. After selecting the current region, you can further narrow the scope of the project by selecting the current country. ODU power supply. Select the outdoor units that meet the local electricity system. IDU power supply. Select the appropriate electricity system and the software will select the IDUs that meet the requirements automatically. Power supply frequency. In general, we only need to do the system setting when the selection software is open for the first time, and these settings will be saved as default. Next will be the calculation correction. The first one is altitude correction. It should be taken into consideration when the altitude is high. The second one is the dust stratification correction. In general, for cooling only, we recommend dust coefficient of 1.1. For heating only, we recommend 1.15. For both heating and cooling, we recommend 1.2. This sample project required both cooling and heating, so I will choose 1.2. Unit setting, including length, pipe diameter, load, power, capacity, weight, temperature, flow, pressure, and area unit setting. We can modify them according to the local requirement and habit. Other setting. It is mainly for the setting of software language. Currently, software supports Mandarin, English, German, Dutch, Polish, and Russian. After language selection, we need to restart the software to complete the modification. Now, system setting is finished. Next, I will demonstrate on the project operation. New project. Add project information. Project name EX. Project location. If you have selected the region and country in the system settings, you only need to select the city in the drop-down list. For now, I take Beijing as an example. After we select the project location, the design conditions of the project are available. The outdoor conditions are corresponding to the location of the project. If you think that the design conditions are different with the local conditions, you can manually modify the values. Or if your city is not included in the software, you can choose the nearest city and modify the name and design conditions based on the project location. Project area. Fill in according to the actual situation of the project. Project requirements. Cooling only, heating only, both cooling and heating. For Beijing, both cooling and heating are required. Other information: customer name, telephone, email, consultant, or designer. We can fill in the details according to the actual project. This software supports with drawing mode and also without drawing mode. With drawing mode, the software will measure and calculate the pipe length automatically according to the base map. Without drawing mode, manual input is required. If there is a need to modify the project information after the project was created, click on the information and modify. After the modification, click OK. If the modification was made after the completion of equipment selection and pipeline drawing, the equipment needs to be updated and recalculated. Here shows the current project with drawing mode. First, we need to switch to the layout page for some drawing operation. Double-click Layout. We can see that the system will prompt us to choose single system mode or multi-system mode. Let's talk about the difference between single system mode and multi-system mode. For the single system mode, drawing needs to be inserted separately for each system, and the piping diagram will be automatically saved. For multi-system mode, multiple systems share the same base map, and the piping diagram needs to be manually selected and saved. Before I insert the base map, I will give you a brief introduction to the toolbar. From the left side, if you want to draw refrigerant pipe, condensate pipe, and control line, you need to select the corresponding system first, then only do the design. Insert floor plan equipment layout. After the selection, click Equipment Layout. The equipment will be automatically arranged on the plan. Auto piping, refrigerant pipe, refrigerant vertical pipe, switch box for R Series 3 pipe products. Calculate. Recalculation is needed for the system with manually draw pipeline or any changes on equipment and pipeline. Expansion plan. I'll show you later in the actual operation. Save during project operation. Export. Base map, equipment and pipeline are exports together. Support picture, PDF, and DWG format. Print. Select the drawing and print directly. Standard function. Move, undo, zoom. Configuration, orthogonality, display line width, pipe length, pipe diameter, floor plan, room, log floor plan. A detailed description of the configuration. Open, including color, text height, font style, line width, block, label, and other. In all these settings, most commonly used are block and label. Device type. There are two types we can choose: image or DWG format. Device block scale. Select one according to the system default. So when we import the plan, the base plan ratio will be 1. Other scales are available by default. We can adjust the scale again if the drawing display is too large or small. Label mainly includes the selection of prefix for refrigerant pipe and condensate pipe, the separation symbol between annotation contents, and the selection of the annotation contents of IDU and ODU. Other, condensate pipe. What will happen if we cancel the selection? You can observe that the condensing system on the top left corner has disappeared. If there is a demand for the condensate pipe drawing, then we have to check it back. If we tick the third option, it might affect the running speed of the software, especially for the large system. The last one is the space of automatic equipment layout. Under normal circumstances, the default spacing is satisfying. If the equipment overlap during auto arrangement, we can solve this problem by adjusting the spacing. Project demonstration. Insert floor plan. Select insert position. Choose drawing. Here we can see that the software supports PDF, DWG, and image formats. We take PDF drawing as example. Choose the drawing and open it. Follow the instruction of the software. Select 2 points on floor plan and enter the actual length. From the drawing, we knew that the actual distance between these 2 points is 7.2 meters. Thus, enter it in actual length row. Rotation. The rotation angle in the software is based on counterclockwise direction. As to get back to normal drawing position, we need to rotate it 90 degree counterclockwise. Select 90 degree, click OK. Now, floor plan has inserted. Next, room area measurement. Before the measurement, we first add floor and room. There are 2 ways to add floor and room. First, switch to Edit and add floor and room from the toolbar. Another way is from the right side of the software interface. Right-click to add floor and room. When the floors and rooms are added, we can edit the information. Select the floor. We can modify the floor name, the bottom elevation, and the height. The default floor height is 3 meters. Select the room. We can modify the room name, fill in the room area, the cooling and heating load, and the cooling and heating index data. I will add more rooms for the indoor unit selection demonstration. Next, I will introduce about area measurement. Two methods. One is the rectangular measurement for the regular shape. Another method is the polygon measurement for the irregular shape. First, I'll show you the rectangular measurement. Taking room 1 as example, select the first point and its diagonal point. The room number and area are shown on the drawing. For polygon measurement, select the first point, second point, and so on, then return to the starting point. The room number and area are shown on the drawing. Measure the area for other rooms. We measured room 3, 4, and 5 with software. Manually input area for room 6, 7, and 8. Assuming the area for room 6, 7, and 8 is 20 meters square, 18 meters square, and 20 meters square respectively. Now, the area of the room and the area of the floor are reflected here. The equipment will be automatically positioned at the middle of the room if the room area was measured by the software. However, for the room with manually input area, the equipment won't be located. After the completion of area measurement, we determine the load. We already know the room area. If we have the load index, then we can get the room load. If the load index for each room is different, we can fill in the cooling and heating load index separately. Assuming that room 1 is different from other rooms, we fill the load index separately. We should pay attention to the unit before entering the index. We can see that room 1 has the cooling load and the heating load now. If other rooms have the same cooling and heating load index, we can modify them all together. Select room 2, hold shift, then select room 8. Now all the rooms are selected. Fill in the cooling and heating load index. And we can observe that all the rooms are with cooling and heating load. Next will be the selection of indoor and outdoor units. There are two methods to enter into indoor and outdoor unit selection interface. First method is from the left side column of Layout Interface. Outdoor Unit, Indoor Unit, All Fresh Air Unit, and AHU are shown here. Select the appropriate indoor unit type. By using the high static pressure ceiling ducted as example, drag the high static pressure ceiling ducted to the working zone. It is the same operation for outdoor unit. The second method is to switch to the configuration interface. We can add the indoor unit either by right-click on the working zone or from toolbar. Choose the floor, room, and the cooling and heating load for the specific room will be shown. For installation height, fill according to actual condition. For this example with floor height of 3 meter, we assume that the indoor unit installation height is 2.7 meter. Choose the indoor unit type. We can see from the interface, there are two types of indoor unit selection mode. The default mode is select based on room. With this type of mode, the software will recommend one or more indoor units according to the room load. Another type is select based on IDU. With this mode, software will recommend an indoor unit which can meet the requirements. If the recommended IDU does not meet the requirements of the actual project, we can select it manually. Click plus and complete. Select based on room. For room 1, if we want to choose 2 indoor units, just select the suitable indoor unit and click plus. If all are completed, click OK. If you wish to continue, click Apply and continue to complete for other rooms selection. After we have chosen the model, the basic parameters for the selected models will appear at the right side. We can edit the IDU details, accessory, wired controller, wireless controller, wireless receiver, external pump or filter. Working conditions. When the operating conditions of a room are different from other rooms, we can set the operating conditions of this room separately. OK, now the indoor unit selection is completed. Next, choose the outdoor unit by right-click or from toolbar. Enter the floor number and installation height. After entering the installation height, the software will calculate the height difference between the indoor and outdoor units according to the installation height of the indoor units input earlier. The maximum piping length, the default piping length of 7.5 meter is our testing condition. Thus, we do not need to modify. After our drawing is completed, the software will calculate the piping length automatically and perform capacity correction. Same system. In multi-systems project, if we have completely same systems, we can input the number of same systems and the software will count the materials and reflects in the report. Choose the outdoor unit. Take S series as example. Two methods. Choose the outdoor unit based on the capacity ratio or let the software recommend the outdoor unit for us. Now, equipment selection has completed. switch to Layout interface for equipment layout and piping drawing. Equipment layout. From here, we observe that the equipment for room with area measured by the software are positioned at the middle of the room, whereas the equipment in the room 6, 7, and 8 with the manually input area are not positioned in the room. We need to manually move the indoor units to the corresponding room. The equipment for room 1 to room 5 needs to be adjusted appropriately. There are two ways to move. One is select move. Select the indoor unit, space, and move it to the appropriate location. The other way is select the indoor unit directly, and we can see that there are 3 points. When we choose the middle point to move, the indoor unit and the content will move all together. When we select the point below, only the content is moved, and the right point is for the rotation of the unit. Now, move the indoor units to the appropriate position. The room area display can be turned on and off based on the requirement. Next will be the pipeline drawing. It is advisable to use manual drawing for with drawing mode. Draw the main pipeline for the refrigerant pipe and connect the indoor units. The excess pipeline should be deleted, otherwise the calculation will be affected. Draw the condensate pipe, assuming that the centralized drainage is adopted and is located at here. Draw the main pipeline for condensate pipe and connect to the indoor units. Draw vertical pipe. Set the vertical pipe number, current flow, and pipe length. Let's try to calculate and see what will happen if excess pipeline are not deleted. The system will prompt us for the mistakes on the drawing. Now, delete the excess pipeline, calculate again. Calculation success. The pipe diameter is changed from 0 to the specific data, and the branch pipe model is also marked on the drawing. Control system. To make the surface clear, close the base map. For the control system, we usually use automatic wiring. The software will choose the shortest path for connection. If there is an overlap or intersection, we can adjust it manually. Auto wiring. Here, we can see that the control line and the picture frame are crossed. Delete the cross section and manually connect. Next, I will introduce 3 other operations for the control system. First one is replace the controller. The second one is group control with only one controller. And the third one is group control with 2 controllers. Demonstration 1. Replace the HYXE-M01H of indoor unit 3 with HYXE-J01H. Switch to the configuration. Choose accessory. Choose IDU3. Choose J01H. Click OK. Switch to the layout. We can see that there is no changes on the controller of IDU3. Right-click, Update Equipment. Now the controller is changed. Demonstration 2. Take 2 indoor units of room 1 as example. Select the indoor units. Right-click, Add Group Control, and select the controller. Demonstration 3. Group Control with 2 controllers. Take 2 indoor units of room 1 as example. Select the indoor units. Right-click, Add Group Control. Select the controller 1 and 2. With this setting, both J01H and M01H can control these 2 indoor units. Demonstration on control system is completed. If the project needs centralized control, switch to Centralized Control System interface. Double-click. Drag the outdoor unit to here and drag the selected controller to this place and click Generate Scheme. Next will be the project export and report. Before that, I'll show you the expansion plan. Export and print. Expansion plan. We can see the expansion of the indoor and outdoor units. Export. Support picture, PDF, and DWG format. I'll save as picture format. Save and open. Export. Name, format, support picture, PDF, and DWG formats. I'll save as picture format too. The difference between these two is the expansion schematic without base map. Another is the actual drawing content with the base map. Print. Select the print area, select the printer, and click Print to complete. The following is an introduction to Project Far Export and Report.